Hi, I'm Chris Bertrand, and I'd like to present to you subtraction using the in-the-hole method. This is an alternative to the traditional borrowing 10 method that I've discovered or rediscovered, and I've created this notation and guidelines to make the in-the-hole method easy to follow. As some background, I was working with my son doing his grade 2 homework, and I found it challenging to explain to him the borrowing 10 method. This is a method that I learned in school, and found it overly complicated, hard to explain, and decided that there had to be a better way. If we look to the right of this screen, we can see an example of a subtraction where you'd have to use the borrowing 10 method. So 624 take away 556. So we start with the first column on the right, and we say 4 take away 6, it cannot be done. So then we have to borrow 10 from the second column where the 2 is sitting. So we scratch the 2, that leaves us with 10. We bring the other 10 over in front of the 4, giving us 14. We can then say 14 take away 6, which leaves us 8. We then go 1 take away 5 in the second column, and we're stuck with the same problem. It can't be done. So we go to the next column over, and we borrow 10 from the 6. We scratch it, and that gives us a remainder of 5. And once again, we carry the extra 10 over to the second column, giving us 11. 11 take away 5 gives us 6. And then 5 take away 5 gives us 0. So you can see that we've had to go through multiple steps of scratching and borrowing 10 to get to our final result. So the purpose of this in-the-hole method, I want to create a simple, quick, less error-prone method for subtraction that is easy to teach. So the notation is quite simple. I've got a circle, which would denote values in the hole. And then I've got square, which would denote supporting a friend. And we'll get into this. The supporting the friend is similar to the borrowing the 10, and you'll see how that works shortly. The first rule of 5 that defines the steps necessary to perform the in-the-hole method is if you can perform a subtraction in a column without a negative difference, then do so. Or in more traditional borrowing 10 speak, if you can perform the subtraction without the requirement to borrow 10, then do so. So in this example, 5 take away 4, the result is 1. The second rule is if the first rule does not apply, then we reverse the subtraction and we notate it as in the hole. So we start by saying 3 take away 6, can't be done. We reverse it and we say 6 take away 3. That gives us a difference of 3. We record that and we mark it as in the hole. The next rule is if the previous column's difference was in the hole and this column's difference is in the hole or 0, add 1 to the column's in the hole value, because we need to support our friend in the previous column. So in this example, we've started off with 3 take away 6. We're using the second row. We've denoted that as 3 in the hole. We come to the next column, 2 take away 3. We know that the answer is 1 in the hole, but we're going to add 1 to it to make it 2 in the hole to support our friend. The fourth rule is if the previous column was in the hole and this column is not in the hole and not 0, then perform the subtraction and notate a 1 as support a friend. So if we look at this example once again, we got the first column on the right is 3 take away 6. That gives us 3 in the hole. We come down to the second column and we have 6 take away 3. So we can do that. So we record the 3 and we'll call that our interim result. And then underneath the 3, we record a 1 in a square box as supporting a friend. So the reason we put that 1 in the square box is that we're next to a column that was in the hole. And that's rule number 4. So the final rule is really the steps required to finalize your result. So let's start with the red portion. It says subtract the in the hole value from 10. So we start off, we say 10 take away 3, and we record the difference of 7. Then in the blue we say, when we have an interim result and the supporting the friend, just subtract the supporting the friend value from the interim result. So 3 take away 1 is 2. And finally, in purple, when we have a value that is not in the hole and it's not supporting a friend, just pull that down to your final result. So that would shows the one coming down to be 100 in 127. So I'd like to show you some examples of how this would work. I'm going to use the same example that we started with at the top, where we showed the scratching and the carrying of 10, and then we'll compare this result with the other result and the complexity of this method compared to the other method. So let's start with 4 take away 6. The result is 2 in the hole. 2 take away 5 should be 3 in the hole, but we're supporting a friend, so we're going to record 4 in the hole. 6 take away 5 is 1, but we're supporting the column on the right again, so we're going to say 1 and 1 supporting a friend with a square box. So now we can finalize the result. In the first column, 10 take away 2 is 8. 10 take away 4 is 6. And 1 take away 1 is 0. So you can see that it's fairly clean, and let's compare what the borrowing 10 would look like compared to this notation. So it's my position. I think it's quite clear when you see these two side by side that the in the hole method is cleaner than the borrowing 10 method. The next example will show what happens when we have a value of 10 in the hole. So we've got 103 take away 94. We'll start with the first column. 3 take away 4 is 1 in the hole. 0 take away 9 is 9 in the hole, but we're supporting the previous column, so we're going to say 10 in the hole. 1 take away 0 is 1, but once again we're supporting the previous column, so we're going to say 1 supporting a friend. Now let's just finalize the result. 10 take away 1 is 9. 10 take away 10 is 0. And 1 take away 1 is 0. In the next example, what I want to show is what happens when we have a 0 result, but it's supporting a friend. So let's follow this through once again. 5 take away 6 is 1 in the hole. 2 take away 3 is 1 in the hole, but we're supporting a friend, 2 in the hole. 1 take away 1 is 0, but because we're supporting our friend, we're going to make that 1 in the hole. And this is the purpose of this example, is to show that. Then we've got 9 take away 0 is 9, but we're supporting a friend. So now we just finalize the result. 9, 8, 9. 9 take away 1 is 8. So let's go to the next example. In this example, we're going to show how to deal with multiple zeros. Of course, this can get pretty tricky using the borrowing 10 method. So in the whole method, the same basic 5 rules apply. 0 take away 2 is 2 in the whole. 0 take away 7 is 7 in the whole. We're going to support our friend, 8 in the whole. In this column, we say 0 take away 0 is 0, but we're supporting our friend, 1 in the whole. Once again, 0 take away 0 is 0, but we're still supporting our friend, 1 in the whole. 1 take away 0 is 1, but we're supporting our friend. Now let's finalize our result. 10 take away 2 is 8. 10 take away 8 is 2. 10 take away 1 is 9. 10 take away 1 is 9. And 1 take away 1 is 0. So in this example, I just want to show a mixture of having to go in the whole and not within the same subtraction. So let's start off with the far right column. 0 take away 2 is 2 in the whole. 7 take away 4 can be done, but we're supporting a friend. So let's put the 3 as our interim result and the 1 as supporting the friend. Next column, we've got 8 take away 3. Well, that can be done. 5. 5 take away 3 can also be done. 2. 6 take away 7, we are now going in the whole. And then 1 take away 0 is 1, but it's supporting a friend. Let's finalize the result. 10 take away 2 is 8. 3 take away 1 is 2. With the 5, we'll just pull it down. The 2 as well just comes down. 10 take away 1 is 9. And 1 take away 1 is 0. The next example, I like to show that this method does work for large subtractions as well. So we'll just follow it through as we did with the other examples, following the same rules. 7 take away 8, 1 in the whole. 8 take away 5 is 3, supporting a friend. 1 take away 3 is 2 in the whole. 5 take away 4 is 1, supporting a friend. 2 take away 3 is 1 in the whole. 6 take away 8 is 2 in the whole, supporting a friend is 3. 0 take away 9 is 9, supporting a friend is 10 in the whole. 5 take away 8 is 3, supporting a friend is 4 in the whole. And 8 take away 4 is 4, supporting a friend. Then we can finalize the result. 10 take away 1 is 9. 3 take away 1 is 2. 10 take away 2 is 8. 1 take away 1 is 0. 10 take away 1 is 9. 10 take away 3 is 7. 10 take away 10 is 0. 10 take away 4 is 6. And 4 take away 1 is 3. So once again, very clean and can be done pretty quick. And in summary, the in the whole method is simple, it's quick, it has a clean notation, no scratching or borrowing. We've got a system that's less error prone than the borrowing and is easy to teach. If you find a problem that cannot be solved with this method, please let me know and I will revise and update. Thank you.